All right, guys, so we're going to get into some other special parts of a circle, including what's called the arcs, and talk about some properties of the chords. So the first thing is to go over some vocab, and the first thing in vocab we got to talk about is what's called the central angle. And the central angle is located directly in the circle, in the center of the circle, and is created by the two radius or radii coming from that center of the angle, center of the circle to the edge of the circle. So this is, again, the vocab where angle whose vertex is the center of the circle, using the radii as the sides of the angle. Next, you have what's called the minor arc, and the minor arc is part of the circle that measures less than 180 degrees. Next, you have what's known as the major arc, which is part of the circle that measures more than 180, but less than 360 degrees. And a major arc is named with 3 letters. So you would name this major arc down here A, C, B. And to name the minor arc, you would name it A, B. And then you have what is known as a semicircle, which is just half of the circle, and its endpoints are going to be on the diameter of the circle. So you would have from this point on the diameter all the way down to the other point on the diameter, and that's known as a semicircle. All right, so we continue some vocab here. The measure of the minor arc, right, is the measure of the central angle. So you'll see the minor arc here, GF, is equal to the measure of the central angle, GHF. So 60 degrees for the central angle, 60 degrees for the minor arc. And then the major arc, right, is a difference of 360 degrees with that minor arc. So if I go back, I can show you here the measure of this major arc from E to F to G would be 360 degrees minus this part here, EG. And if I do some math, 180 is that straight line, the diameter. And if I take 180 and subtract 60 from it, I get 120 here for EHG. So EHG is 120. If I take that 120 and subtract from 360, I'm left with the measure of that major arc from E to F to G of 240 degrees. And semicircle, again, we talked about it before, but remember, a semicircle has a total measure of 180 degrees. So from E around to F, that measure of that semicircle is going to be 180 degrees. Now we talk about what's called the arc addition postulate, the same as the angle addition postulate, segment addition postulate. We're just going to take 2 parts of an arc. So the whole arc here is ABC. So from A to B to C, I can cut that in half, or I cut that in parts. I can take the measure of angle or arc AB and add that to the measure of arc BC, and I should get the entire angle if I put them together. Notice the arcs over the major arc ABC and the arcs, the symbol over the measure of the minor arc AB and the measure of minor arc BC. So that would be your notation to identify the difference between an arc versus an angle, or a segment and line. You use this little curved line over top of the letters to identify the points. Also notice that the major arc ABC tells you exactly how to identify the arc on the circle. So if you start at A, you're going to start at A. You're going to go through B, since B is the second letter. So you would go A through B and end at C, since C is the last letter in the name of that arc, which is major A, B, C. Okay, so that's how you would name the major arc versus a minor arc, which all you need to do is the 2 letters, and you take the shortest path. So from A to B, right, shortest path. From B to C, the shortest path is the name or is the location of that minor arc. Here we get into some practice. If you want to pause it here and then come back with the correct answers, go ahead and do so. All right, here we go with the examples given. So the measure of each arc, notice that DG only has 2 letters, so we're going to name that a minor arc. So minor arc DG is equal to DF, or the measure of arc DF, plus the measure of arc FG. So DF is 80, and the measure of FG is given to us as 70. So I can add those together because we have an angle addition postulate that says DG is equal to the parts added up. So 150 would be the total measure of the minor arc from D to G. So now we're looking at a major arc here for letter B, DGH. So from D, go through G, and at H, and that's the major arc we're talking about. So if I put these parts together, that adds DG plus GH. And if I can identify those parts, we already know that DG is 150, we just found. If I add that to GH, which is 120, you end up getting a major arc DGH with a measurement of 270 degrees. Notice we're all referencing the central angles here. The central angles are equal to the arcs. And now we're going to go into our last one here, where we're asking for the measurement of the minor arc DH. So DH is the only one that doesn't have a measurement to it. So we're going to take 360 degrees, which is the total measure of a circle, and subtract that major arc, DGH, which we just found to be 270 degrees. So I'll subtract 270 from 360, and you're left with the minor arc of DH, which is 90 degrees. So that's a couple of examples for you using the arc addition postulate. All right, now we're going to talk about some special theorems that deal with chords, and we're just going to write these down so that we have them and we can apply them if we see problems that deal with these types of properties. So the first one says, theorem 10.4, do not worry about remembering the numbers to the theorems, just remember the properties of the chords. So in this case, we have a circle with 2 chords drawn in it, and the 2 chords are congruent in length. So you'll see the chord AB is congruent to chord BC. So it says that if you have a arc AB and that's congruent to the arc BC, that is only true if the chords that create those arcs are also congruent. So the segments in here, the chords, need to be congruent for the arcs to be congruent. Next, we have theorem 10.5. This one says if the diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arcs. So it's saying here that diameter, here's our diameter going through the center. It's going to be perpendicular, and if it's perpendicular, it must bisect this chord DF, which then in turn also bisects that arc DF. So it makes DE congruent to EF, and it also makes the chord DG, the arc DG congruent to the arc GF. So it splits both the chord and the arc in half if the diameter is perpendicular to the chord. All right, next we have theorem 10.6, where it says if one chord is perpendicular to the bisector of another chord, then the chord is the diameter. So this is just the converse of the last statement, where we said if the diameter is perpendicular to a chord, it's congruent. This one's saying that if a chord is a bisector, then the chord is going to be the diameter. So here it is. JK is now going to be the diameter because it is perpendicular and it bisects the chord. And our last theorem here, 10.7, says in the same circle or in congruent circles, if two cards are congruent, if and only if they are equidistant from the center. So this is saying that the center is equidistant because we have a segment here, EG and EF. That means that AB is going to be congruent to CD, right? So these segments have to be equal for the chords to be equal, and vice versa. All right, here's some practice problems. If you want to pause it and then come back with we'll give you guys the correct answer. So take a second here, pause it, and come back to the correct answers. All right, so here we go. This one asking in the first practice problem is asking to find the measure of each arc, given that BD is the diameter. So knowing that BD is the diameter, we know that from B to D is going to be 180 degrees. All right, so I switched programs so I can draw in the picture for you guys and help you guys out in identifying different parts and measures. So we talked about before, right? BD is the diameter. So we know that BD is going to be the diameter. So that means that this measure here is going to be 180 degrees. All right. That means that the other side will be 180 degrees as well. So we can take this 148 and subtract it from 180. And plug that in for the missing part here, which would be, what, 240, 32? It's a good idea to plug some stuff in on the diagram like we've been doing all year of things we know or we can identify. So now that we come down here to the measure of CD, we can identify CD as being from C to D. Remember, it's a minor arc, so we take the shortest distance. So it would be 148 degrees, same as the central angle. So this is going to be 148. We then look at the major arc from C to D to B. So from C, we're going the other way. We're going from C to D. So we're going to come around this way, right? The name of the major arc tells us where to go in the circle. So from C to D all the way up to B. So that major arc is everything except for this 32 degrees. So we can just take the total of the circle is 360 and subtract that little bit of arc that is not included, which is 32 degrees. And that gives us our answer for the measurement of major arc CDB of 328 degrees. Now that we have that, we can then go and answer the last question, which is talking about the measurement of the major arc BCD. So from B to C to D, and actually we already know this because it's the other side of the semicircle on the left. So the side on the right from B, C to D must also equal 180 degrees because the total is 360 in a circle. So actually this major arc is going to be known as a semicircle. Now if we come over to the right hand side, the problem on the second problem is we have a bunch of parts, a bunch of arcs, a bunch of central angles, and we're just missing this little bit over here, which we can easily fill in by adding these guys up and subtracting from the total in a circle, which is 360 degrees. So I'll take 360 and subtract the 60, 82, and 100, which if I add these guys up, I get 142, 242. So if I subtract that from here, I get, 118. So 118 degrees is this central angle from B to A to E. So from BA to E is 118. Now let's see if we can use that information to help us out. So from B to D is the first arc we're talking about. So this would be a minor arc, right? 2 letters from B to D. The shortest path is right here. So from B to D would be equal to this 60-degree angle plus that 82-degree angle, which gives us 142. And now we'll look at the second guy. And the second guy, it looks like a major arc because it's 3 letters, right? So if I start at B, it tells us exactly where to start and to follow through. So we're going to go through E all the way to end at D. So this includes this arc we found, or the central angle we found is 118, and also it includes the 100-degree angle here. So if we add those two together, we get a total measure of 218 degrees. And lastly, we're going to look at the arc BE, which should be a minor arc since it is only 2 letters, and it goes from B to E, which is actually the angle we found as 118 degrees because the central angle, again, is the same as the arc it's creating. So it would be 118 degrees. All right, so that does it for our practice problems dealing with the arcs and chords. There will be some additional practice problems for you guys to take a look at.